Okay. The last matrix, excuse me, that we saw, and I have it written up here, but it's not where you can see it. Last matrix that we saw was the matrix 3, 2, 4, 3, 0, 1, and -3, -2, 1, which was obtained by multiplying the identity matrix on the left by by an elementary matrix, multiplying that on the left by an elementary matrix, etc. Okay? So there are, if you put 5 elementary matrices to the left of the identity and multiply it out, you're going to get this. Now, what we really want to look at is what you do when you reduce this matrix. And in the process of reducing this matrix, we want to look at the elementary matrices that we use. If you understand what we said before, you know that we start with this matrix, which is of course the last matrix that we got, and multiply it on the left by this matrix, which undoes the operation, the latest of the row operations. Okay? So that's the first one that's going to go to the left of A if we want to reduce it. So we're going to call that E1. Okay? So if we multiply E1 by A, well, here's A, and we multiply it by E1. Okay? So we're going to take that last matrix that we got, we're going to multiply it by this, and that's going to undo a row operation. Okay? Then we're going to multiply by this matrix, and I've labeled that E2. So we're going to multiply that, we're going to get E2 multiplied by E1A, and that's going to undo the next to the last of the row operations we used in building this up from the identity. Then we multiply that by E3, which undoes another of the row operations, and then by E4. Now this is just equivalent to doing the row operations that reduce this matrix to the identity. Now you have choices in how you do the row operation. You might not even do it in the order of these inverse matrices, but this is one of the ways in which you could do it. You know, be a reasonably good way. Okay, well then, having multiplied all this by E4, which undoes the second row operation, we multiply by E5, which undoes the first one, and that's going to give us the matrix I. Okay, so what we do is we list E1, E2, E3, E4, E5. Okay? Now these were inverses of the matrices, of the elementary matrices we used to build up A. But now we want to think in terms of reducing A, so we're going to call these the matrices we used to reduce A, not the inverses of the matrices we used to build up A. And we're going to call the matrices that we used to build up A the inverses. That might be a little confusing, so think it through. But let's see how that works. Okay. So here are the original calculations. Okay. Now again, here's the matrix that we've called A. I've written A here as well, not in red, but there it is. The last row operation, or actually it was 2 row operations, because it's represented by this matrix. Okay, if we want to start to work backwards from here to the identity, we'd want to first multiply by the inverse of this matrix. And this is the inverse of the matrix that we called E1, so that's going to be E1 inverse. And then next thing would be the inverse of this matrix, which we had over there. We called it E2. So this matrix is E2 inverse. And this matrix is E3 inverse. This will be E4 inverse. This will be E5 inverse. Okay? Now, how are we going to use the inverse matrices? In what order are we going to use them? Well, you've seen that if we start with A, which was down here, and multiply by this matrix, then by this one, then by this one, then by this one, then by this one, we get back to the identity. How are we going to represent that? Okay, well, one thing we can write here, just formally, I mean, we could skip right to the way we represent the thing, but let's confuse the issue a little bit so you have to think. Okay? And I'm not really trying to confuse the issue, but let's observe that, first of all, how did we get A? We multiplied it by this matrix on the left, then on the left by this. Then we started with the identity and multiplied it on the left by this matrix, on the left by this one, and so forth. So what did we do? We started with the identity, multiplied it on the left by this matrix, which is a matrix we're calling E5 inverse, because it's the inverse of this matrix over here that we originally called the inverse of this matrix. Well, this is the inverse of this matrix. We hadn't given this matrix a name, so if we call this matrix, if we choose to call this matrix E5, we're going to have to call this one E5 inverse since they're inverses. If you have a little confusion about the notation, hopefully that helps, but you know, we never know. Okay, so we multiply I on the left by this matrix, which is E5 inverse. There it is. And then on the left by E4 inverse. And then on the left by E3 inverse, by E2 inverse, by E1 inverse. So the matrix A is this. And of course down here we've written out the fact that if we multiply by E1, E5 down through E1, multiply A by that sequence of matrices, we get I. Okay? Well, you know, what does that mean? Well, among other things, it means that these matrices, E5 through E1, if you multiply them out, you get the inverse of the matrix A. Because the inverse times the matrix equals the identity. The inverse is the matrix, which when multiplied by the original matrix gives you the identity. Inverses multiplied together give you the identity. Okay? Also, A is E1 inverse through E5 inverse times I. Well, the identity matrix doesn't change anything, so you could as easily say that that equals E1 inverse, E2 inverse, E3 inverse, E4 inverse, E5 inverse. Okay, so that's what the matrix A is. And then does it make sense that if you multiply this matrix by this matrix, which I said was the inverse, you should get the identity? Well, let's see how it works. Okay, there are many ways that we could slice this, many ways we could look at it. So the way we actually did it in class, I said, okay, A equals this, so I equals what matrix times A? Now, forget that I gave it away down there. In class, the first response I got was, well, okay, the I then is E1 times E2 up through E5 times A. Seems pretty obvious. We know it isn't right because we know that's the inverse down there. So